Hey everybody, here's a tutorial on how to use Excel and all that jazz. Okay, so here I've already have some data that I've inputted into Excel. I have 4 different springs, notice it's one more than you've had, and a bunch of periods and a bunch of masses that I tested it for. So one thing that you might want to do, since we're working in grams, is you might want to convert to the mass of the bob in kilograms. Now, you're going to be doing this a lot in Excel, just converting numbers into different numbers. So it's easy to just plug into Excel and let Excel do the math for you rather than doing it by hand with a calculator and then plugging the number in. So we know that in this situation, a kilogram is 1,000 grams. So to convert from grams to kilograms, you just need to divide by 1,000. So you start out with pressing the equal sign. It says that this cell is equal to this divided by 1,000. You might see something like A or B's or column B's in yours. Mine's a little set up a little bit differently, so in this situation you see RC and -1 in the brackets. That's just how they reference the cells, so don't worry about that. So I press enter and you notice that it converts the mass into all these things. And then I can take this and I can just copy them down a row, and it should hold, and notice that it automatically converts them all the way down. So very, very quick, very, very easy to do your conversions. As long as you get the math right the first time, you won't have to worry about it anymore. So then we have the mass of the bob in grams, the mass of the bob in kilograms, and in the lab I asked you to plot, in one situation, period versus the mass of the bob. So let's do that. One easy way to do that is you just go to insert and you click on scatter plot, and you go to that first one, and it's going to come a totally blank chart that's pretty much useless to you. So what you want to do is you want to right click on it and you want to do select data right there. So when you select data, click on that, and then you're going to add right over here. So it says, alright, the series name, well, okay, that's going to be, I guess, period T versus mass, M. And then my X values are going to be the horizontal axis. So the horizontal axis is going to be the mass of the bob. So I'm going to select them over here. Alright, I'm going to pick them up. And then I'm going to get my Y values. And my Y values are the periods. It's period versus the mass of the bob. And you see, oh, okay, well, you get that kind of pattern where you see that the period is kind of increasing with the mass. Okay, well, I'm going to OK that, and I'm going to OK that too. Over here now we have our finished graph. I'm actually going to get rid of that because that's kind of annoying to me anyway. You can keep it on your chart if you like it. I'm going to have that over there. It came back. And then I just clicked on this chart layout because then it gives me the axis titles. I actually type them in and it's really easy. So the axis title for this one is going to be period in seconds. Make sure you include your units. And this one is in mass in kilograms. Okay, bam. Okay, so this is for, and I'm going to edit this. I'm going to say, all right, this is for the spring with K equals 33.5 newtons per meter. Okay, so newtons per meter. Oops, I didn't capitalize that, and that's okay. I can fix those now. So now we have our graph, and well, you want to make more graphs. Well, you realize how quickly that was, how quickly I did that, and really it's pretty much exactly the same thing. So in just a couple moments, what I'm going to do is I'm going to make 3 more graphs for each one very, very quickly, and you're going to see why Excel is so useful in terms of making those charts very quickly for you and accurately for you. Okay, so once again, I'm going to do an insert. I'm going to do a scatter plot. I'm going to select my next round of data. It's going to be this guy. Oops, that was my X value. My Y value. Series name here is going to be 41.3. And I'm not going to label the axes for now. I'll label them later. And notice I'm just popping these graphs out, and it's not taking me very much time. Probably like just a couple minutes overall for all of them. This is okay, bam, bam. All right, and then now keep on going. I'm gonna do one more. Okay. Now, if you look at this, you notice that all these lines look pretty linear, right? So they look pretty linear. I mean, but you notice that they're slightly curved at the end, especially on this one. You can kind of see it on these last ones. So what I'm going to do is I'm going to add a trend line. I'm going to go to what I did in order to do that. Let me just repeat that really quick for you. Sorry, I did that really quickly. You're going to click on one of these dots. You're going to right click. You're going to go to add trend line, and it's going to add that trend line for you. Notice how I've selected linear here, meaning like it's a yx plus b thing. I'm going to display the equation on the chart that it has for that. I'm like, oh wow, that R value tells you how good of a fit it is. So that R value is basically saying if this number is closer to 1, the better it is. And I'm like, all right, well, it's 0.98. That's really, really close to 1. But what I'm going to do is I'm going to actually I'm going to add a trend line. I'm going to see something else because I did see that curve. So what curves like that in here? And it's like log or power, maybe no. See, that doesn't fit that well. That new line, power. Whoa, that fits really well. If you see the change from power. So let's go display the equation on the chart. And you see the R value is 0.991, even better than the previous one. So I'm going to delete the old one. And I have this new thing right here. Bam. Okay, that's my equation. Oh, it's kind of odd, right? Kind of odd, because this is telling me that the mass raised to like 0.47 power is equal to the period, which is kind of odd because you've never really seen this characteristic before. So I'm going to check one more time right over here. I'm going to go here. I'm going to add the trend line. Go to linear. I'm going to check it. All right. So that's it. Still 9.8. Still very high. But I'm going to go do the same thing I did before. And I'm going to, oops, wrong window. I'm going to go to power, display the equation. I see, bam. Look how close that is. It's even better. Even better than before. Okay? So you see that these lines that we have here, let me just go out that old trend line. Oops. In this situation, Control Z is always your friend. Okay. Notice how all these things are coming up the raised to the around 1/2 power. So this is why I asked you to do the mass of the bob square root of the mass. Okay, so that's one thing I asked you to plot it by. So what I'm going to do is I'm going to actually delete these graphs. You should keep them if you've made them already. I just need a little more room. I'm going to keep that guy over here. I'm going to use this guy to find me the square root. Now, you might think, all right, now I got to find the square root of the mass and do all that. No, Excel is really, really great. Do the same thing you did before when you converted from grams to kilograms. It's going to be equal to, I'm going to say, now you can't pop in a square root sign because Excel is not going to understand that. But what Excel does is you just type in SQRT and like, oh, return the square root of a number. All right, great. And then so I open my parentheses, and what number is that? I want to return the number here. Okay, so then enter, and it gives you the square root of that. Okay, and you just drag it down, and I'll do that one more time very slowly. So you have that in the corner, this little block, and you just drag it down and you fill it in. Now all those decimals are not necessary, so I'm just going to click on there. I'm going to reduce the amount of decimals so I'm not overwhelmed by that. And so this is the square root of the mass. And so I also asked you to create a plot of the square root of the mass and the period. So okay, let's do that really quick. I go Insert, Scatter, same thing. Right click, I go to Select Data, Add. Now in this situation, the x values are the square roots of the mass, so I just click on there. Right? The y values are the same periods because I haven't changed them. And I go series name is going to be, oh, I don't know. T versus square root of mass. Mass, and then I'm going to finish that. Okay. Now look at that. All right. So I have this new chart. Oops. Let me stop clicking on all the things. Now, if I look at this line over here, I'm going to form the data series. I'm sorry, I'm going to add the trend line. And I'm going to go to, nah, I don't need a setting, so display equation on chart. Now look at that. So we definitely know now that since I took the square root of the mass before, and now this is the new plot of the period versus the square root of the mass, that the period is linear to the square root of the mass, but not the mass itself. So the relationship between the physical quantities of the period of the bobbin, the spring system, is not linear to the mass, it's actually linear to the square root of the mass. And that's a very big thing that we want to find out in this lab. Okay? What I want you guys to do is to continue working on your lab. Now I know I've only provided three springs in the lab. Let me know if this is good enough to get you this square root relationship or linear relationship that might exist between the period and the spring constant. Okay? If you can't get it and you can't get a good reading, explain to me what needs to be done in order to get a better reading for period versus the spring constant. Okay, so if you have any questions, what you can do is you can email me at chiojx@gmail.com, or you can actually message me on my Google Voice number, which is 678-824-4259. Okay, please be sure to tell me whom you are so I know how to respond. Thanks very much.